Hello everyone, welcome back to another physics video. I'm Physics Michael. In today's lesson, we are going to explore the fascinating world of wave superposition. We will learn about the principle of superposition, discover what coherent waves are, understand interference, and study diffraction. Let's get started. Let's begin with the principle of superposition. The principle of superposition tells us when two or more waves meet at a point, the resultant displacement at the point is simply the vector sum of the individual wave displacements. As shown in the figure below, the blue wave and red wave meet and superpose, and a resultant red wave is formed. We can see at each point along the wave, such as A, B, C here. The resultant displacement is just the vector sum of the displacements of the blue wave and red wave. However, the resultant wave pattern is quite complex and irregular. This is because the two waves are not coherent, meaning they have different frequencies or changing phase differences. This makes it very challenging to study and analyze the combined wave. Think of it like two people singing different notes at different times. The resultant sound would be quite chaotic. Now let's talk about something really interesting, coherent waves. Coherent waves are special because they have exactly the same frequency and either zero phase difference or a constant phase difference. When two coherent waves meet and combine, something beautiful happens. We get a very simple regular pattern. We call this pattern interference. Just as shown in the video, the coherent water waves form an interference pattern that is very regular, or it's like two signals perfectly harmonizing the same note. The result is clean and predictable. This is why when we study interference, producing coherent waves is absolutely crucial. You might wonder why waves from two separate sources usually aren't coherent. There are two main reasons for this. First, waves from different sources might have slightly different frequencies. Even if the difference is tiny, this leads to constantly changing phase differences between the waves. Second, while the wave might suddenly change its phase, imagine a signal suddenly shifting its timing. These changes make it impossible to maintain coherence between two individual waves. In order to produce coherent waves, we need to understand diffraction first. Diffraction is what happens when a wave spreads out as it passes through a gap or around the edge of an object. Just as shown in the figure below, the water wave spreads out when passing through the gap. And here's a clever trick we use in labs. We can take a single wave source and let it pass through two slits. The diffraction at these slits produces two coherent waves that have exactly the same frequency and zero phase difference. This is one of the most common ways to create coherent waves for studying interference. And by comparing the diffraction effects at different situations, as shown in these figures, we can see that the diffraction effect is strongest when the width of the gap is about the same size as the wavelength of the wave. Let's look at a practical example. Imagine there is a house that gets good TV reception even though there is a hill blocking the direct line of sight to the TV transmitter. By what wave effect at the hill could the signal reach the house? The answer is B, diffraction. The radio waves from the TV transmitter spreads out as they pass around the hill, allowing the signal to reach the house. This is why you can get TV or radio reception even when you are not in direct line of sight of the transmitter. Here's another interesting example. A student tries to demonstrate interference using two small red LEDs as light sources. Why won't this work? The answer is that the light from the two LEDs won't be coherent. Remember what we learned earlier. Waves from two different individual sources can't maintain the constant phase difference needed for interference. It's like trying to get two different people to sing in perfect unison. It's practically impossible. Let's summarize what we've learned today. The principle of superposition tells us that when waves meet, their displacements add together. Interference occurs when coherent waves meet and superpose. Coherent means waves have the same frequency and constant phase difference. To get coherent waves, we usually use diffraction by passing a single wave through two slits. And speaking of diffraction, remember it's the spreading of waves around the obstacles or through gaps. And the diffraction effect is strongest when the gap width matches the wavelength of the wave. That's all for today's video. Thanks for watching. I hope you now have a better understanding of wave superposition, coherence, interference, and diffraction. I'm Physics Michael, and I will see you in the next video.